Okay, today we go into chapter 4. It is deal with kinetic of particles that we deal with impulse and momentum. Okay, so we will look at what is still, we look at one equation that link with impulse and momentum, and then there's a conservation of linear momentum also. Then we talk about angular momentum. Okay. So I come to chapter 5, chapter 4, impulse. What is impulse? Impulse is when you take force multiplied by time, you get impulse. What is momentum? You learn in static. What is momentum? Oh, you learn in physics. Huh? Mass time velocity. Mass time velocity. Okay, we're going to link these two together to form principle of impulse and momentum. So in chapter 2, you know that you learn about F equal to ma. All the force combined will give you a motion, right? In chapter 3 or chapter 3, there's one tutorial that I mentioned in the slide. I mentioned equilibrium, and then all the force equal to 0. That is previously I mentioned it is about static. No, it's not about static. It's about F equal to ma. The acceleration in the there's one tutorial question that's slanted like that. Acceleration this way. So this one will be have your x and y direction. All the force equal to ma. Fx equal to max and may. What is the value of may? 0. Huh? So in the tutorial question, on the left-hand side is F equal to m0. This one in the slide, it mentioned equilibrium. It means that you need to consider acceleration component and not back to the static that all the force equal to 0. It's different concept. Huh? Okay. So back to our slide today. So still, we look at F equal to ma because we deal with dynamics, motion of particles. So we rederive the equation, not rederive, but recall the definition of acceleration, which is v dv, v dt. Agree? Then you have F equal to m d dt. You pull the dt to the left, you get what? F dt equal m dv. You have dt left hand side, dv right hand side. What do you do? What do you do? You have force dt equal to m dv. You have dt dv. What's that? What? Integration. Right. What do you get on this side? F is what? Constant. Not constant, but can be a constant. So you move F out, integrate dt, what do you get? M constant, move M out. What do you get? Integrate dt, what do you get? Huh? Equal? Integration? Okay, that's t because 1. So t here, of course, here is t2 minus t1. Equal this one? m. So v, but v2 minus v1 if we have a limit. So before we start the class, what is ft? Impulse. What is mv? Momentum. This equation is called equation of impulse and momentum. Principle of impulse and momentum means on the left hand side is impulse, right hand side is momentum. Same like you learn in chapter 3. Principle of work and energy means left hand side is work, right hand side is energy. Same. You can flip the side, no problem. But you only deal with two things. In here, principle of impulse and momentum means you only deal with impulse and momentum. Okay, you put them together, then it form principle of momentum. And how this one come to the picture? We use chapter 2 concept F equal to ma. Okay, so I'll show you on the whiteboard. You do integration. You deal with T1 to T2, V1 to V2. You integrate, you get this equation, right? F dt integrate equal to m v2 minus v1. This is called principle of linear impulse and momentum. Pay attention to linear impulse. What I mean by linear? You learn in chapter 1. You have linear means move in a straight line. Okay, so we will replace momentum with a capital L to represent as a momentum. Just to replace it because we don't want to repeat the same thing. So we'll use capital L to represent momentum. Right? So on the slide here, you see impulse equal to L2 minus L1. Okay. So the unit of momentum is, what is m? M is kilogram. V is meter per second. So the unit of linear momentum is kilogram meter over second. All right. So we will use I to represent impulse. We use capital I to represent linear impulse. So on the top here, if your force is changed with time, then you'll get a plot F versus T, you'll get a curve form. Because your F is in the T function, which means F is an equation with the T. For example, you are given F equal to 10 T squared or cube. You substitute this one inside the integration equation, you find the impulse. Another one is a constant force that you just substitute the constant and multiply the change of time, you get area under the graph with the square area. Okay. So we like to put our equation in a positive form. So again, we put our mv1 to the left hand side plus the impulse plus the momentum after. So equation equal on the left hand side is everything happened before the event. On the right hand side is all the incident after the event, right? So you can write the top one or bottom one, both same. It depends on the question whether it asks you to solve what parameter, right? So okay, so again, this principle of impulse and momentum, what is the benefit of using this one? What are the parameters you have? Force, time, velocity. So if you're given time, you're given force, you need to find velocity, you use this one. Can you use chapter 2 equation F equal to ma? Yes. Because why? This equation comes from F equal to ma. But F equal to ma, you need to find the acceleration. Because F equal to ma, if you're linear, then you have x and y. If you're collinear, you have normal and tangent direction. Right? So same with this one, huh? This one, when the question give you direct instruction, using your understanding in principle of linear impulse and momentum, solve what, find what, or determine what. You need to write this equation or this one. Okay, so if you use chapter 2, you will not get mark, although you get the correct answer, because you do not follow instruction. Understand? Yeah. Right. So you're dealing with momentum, impulse, and final momentum. Before momentum, sum of impulse and final momentum. So if you draw a particles diagram, you can draw the initial momentum is what? mv1. Again, velocity is a vector. So you have a mass with the velocity pointing upwards, v1, plus the impulse. What is impulse? Force and time. So you have a particles, force and time. Impulse is a vector pointing down. You have vector 1, vector 2. Combine these two vectors, you get the third vector. This is the product. You draw vector 1 plus vector 2, you will get vector diagram. Okay, so this one, before go up, then ft go down, you get the final resultant vector. Okay, this one may be part of your assessment when you when you told to use principle of linear impulse and momentum. You will be given the initial state. You need to draw where is the impulse or where is your final momentum. This is called on the left is called initial momentum diagram. Center one is impulse diagram. Right hand side is final momentum diagram. Basically, it's just the completing the vector diagram. Okay. All right. So here, by using the principle of linear impulse and momentum, you can break into x direction, y direction, and z direction. When you use this linear impulse and momentum, you focus on individual component. Okay? Let's say you have two bodies later. These two bodies collide each other. You do not use principle of, if you want to find the properties of each particles, after the incident, you need to break into one for particle A, one for particle B. You cannot group two particles in one, unless there is a special case I'll mention later. Right. So if we have a group of particles inside the system, you learn this one when you come to rigid body. We're now in particles. So we just sum up all the force together. Right? All the force acting on the particle will equal to ma. A is dv dt. Right? So at the end, you will still arrive at the same principle of linear impulse and momentum. Momentum plus impulse equal to momentum. Still the same, right? This one, when you learn about rigid body, how to find center of gravity, you take mass and velocity equal to the sum of mass and velocity of individual particles. Mass on the left-hand side will equal to the sum of mass of individual. So you can cancel. So it means that velocity at gravity was same to the velocity of individual system or individual particles. All right. So this one, you see this one when it comes to rigid body. We'll focus on center of gravity. Right. Let's look at example 1. We have a 100-kilogram crane, original rest at smooth horizontal plane. If a force was given at a certain angle applied for 10 seconds, determine the final velocity and normal force which the surface exerted on the box or crane during the time interval. This one, 80% same as example 1 in chapter 1. Sorry, chapter 2. When you learn about F equal to ma. But here, you add one more time factor there. Okay. How do you start? What do you do? Free body diagram. Okay. So what forces you have? 200, then what else? Weight, then normal force. Why no friction? Smooth surface. So you have weight, you have force, you have normal. Okay. Then kinematic, where is the direction? Where is your positive direction for your motion? To the right, we assume to the right because it seems logic to the right. Can you put to the left? You can, but you'll get a negative sign in your answer at the end. So negative sign means you need to flip the direction of your answer. Okay. So velocity will be to the right. Okay. So kinematic diagram, you can put V, you can put A. Okay. Why you put V there? Because we are now in chapter 4. We're only interested in velocity. Because principle of linear impulse and momentum, we only deal with force, time, mass, and velocity. That's why I put velocity there. Even you put A there, it doesn't help much, right? Unless you are doing chapter 2 question. So you are using the principle of work and energy, and remember, you can break the principle of linear impulse and momentum into x and y direction. So you need to break into x direction, y direction. All right, so on the screen here, I've given you the general equation already. Nico, what is your velocity, mvx1? What is your impulse? Okay. M is what? 100, correct. Vx you need to find 45, then? Okay.
It's same thing.
What is your Vx1? What's Vx1? What is Vx1?
Oh, okay, for 0, right?
Why 0?
Because it's
Okay. Good. All right, so you complete the equation. So all the direction to the right is positive. So the first one, MB x1, 0, because you start from rest. Then you convert your 245 degree into x direction. You'll get 200 cos 45. Time was given 10 seconds. And then the right hand side is your m. M is your 100 kilogram. Again, change all the mass into kilogram. Sometimes the question will put megagram or milligram and so on. Right, so in this equation, there's only one unknown. You solve for Vx2. So Vx2 is a vector, right? It's a vector. So you get your first vector for velocity. So what about y? Y go up, right? So still the same equation, only you change the principle of impulse, linear impulse and momentum into y direction. Okay, so what is Vy in this case? Y is 0. Vy1, what is the value? 0. Okay. Then Fy is sine 45, right? In this case, your W negative could go down, and force, and there's one more, your normal force, right? So inside the linear impulse, you need to consider all the force that you need to extract from your free body diagram. So that's why your free body diagram is very important. If you miss one in your section A, free body diagram section, means the second section of your solution will be wrong already. For example, in this case, if you forget to draw the normal force, you will get the wrong answer for y component. Okay?
As part of part of NC, the normal form.
What is the impulse definition? What is the impulse definition? Force and time, right? And this one is all the force. How many force you have? You have normal force, weight, and 200.
Correct. 2 times we are 10 seconds.
Huh?
2 times we are 10 seconds.
2 times?
Yeah.
Why 2 times?
Because there's 10 seconds in front of NC, right? The normal form.
This is 1. Then
Then,
the second time where?
okay. That means like for every force we should add 10 seconds.
Yes. No. More correctly say is that for every force will create impulse as long as there's a time. No matter is contact, no contact, or as long as the force, friction force also create impulse. In this example 1 is purposely put smooth because we don't want to confuse, we don't want you to have lots of information. But when it comes to assessment, most of the time you won't have smooth. So you need to add in the friction force, and you'll see friction coefficient inside the question. So friction also one of the force. So friction force also create impulse. Just remember that. Okay, as long as you see force in your free body diagram. Okay, so you get your NC and you solve for example 1 of it. Okay. You can also solve in chapter 2, F equal to ma. Then you use the one of the motion equation, which is V equal to V naught plus ACT, because in this case, acceleration is constant. Okay, so you can prove you still get Vx2 equal to 14.1 and Vc equal to, NC equal to 800 something. You still get the same answer, all right? Okay, let's try example 2. You have a train that moving down from top to bottom at a 30-degree surface. Velocity 1 was given 1 meter per second, was pulled by P. So the P is changing with time, P equal to 100 T. Determine the crane velocity 2 seconds after P had been applied. Initial velocity was given, and the coefficient was given now. Now you need to consider friction force. Mu equals 0.3. Can you solve this one? Try to solve this one. I give you maybe 3 minutes or 5 minutes. Try to do this one. Okay, those watching online, you can fast forward till I show you the change in the slides. Huh? Good. So for friction, we have to find the normal force, right? Yeah.
这老师 equation 里面
Huh?
equation F
What is impulse?
dt
What is momentum?
MB.
Principle of work and principle of linear impulse and momentum. So left hand side is what, right hand side is what, right? He asks you to find the velocity 2 seconds. Final velocity. Hmm? Force is what?
Force is
Yeah, force is 100 T. Force is mu k times Newton times normal. Okay. Nico, try to draw your free body diagram on the whiteboard. No need to be perfect, huh? Just I want you to see your free body diagram. Okay. Explain what is 0.3 what?
is
That is friction constant. It's not friction.
friction constant.
It's a friction constant, 0.3. I asked you to draw free body diagram, right? Free body diagram deal with what? 0.3 is not a force. 0.3 is just a number. Why you include number inside free body diagram? 0.3 is not friction force.
Right?
What is friction force formula? You are giving me the constant value 0.3. 0.3 is just a number. It doesn't give you friction force. What is the formula for friction force? How you calculate friction force? Higher friction force. Friction force equal mu. Mu friction. Friction force equal to mu friction. Is it? The formula equal to mu k. This is the correct one, is it? This is what you learn. What is the friction force definition?
K means steady friction force.
Mu k is just a constant.
Then how do you know it's friction?
You know spring, right? What is spring force? What is k? Yeah, you're giving me the constant value now. You're not saying that spring force equal to k. So what is friction force equation? What is friction force definition? You learned in physics. What is friction force? Is it correct in your free body diagram? Correct it? Correct it? What is the friction force again? I don't want to see you in next semester. Huh?
0.3.
Right. You have to write F friction there.
Just get friction. Or like equals to a friction.
If you write a free body diagram, you write mu n, I'll put a question mark. What is this? I don't know what is this. You have to write F friction for this one. Free body diagram. If this is friction, you write F, capital F, friction. Then this one correct. If you only give me 0.3 normal, I'll give you a question mark. I don't know what is that. You can write friction equal to 0.3 Newton normal force, then okay. You don't hang your number there. When you solve question, you don't assume your readers know what you are thinking. You have to write like you are teaching a 3-year-old children. Okay. Based on your free body diagram, why your W pointing that way? Okay. Okay. Your free body diagram now correct. Can you identify where is your positive direction? In your diagram, can you identify where is your positive direction? Go where is positive? Go where is negative?
Yes, it will be negative, right?
Draw on your diagram. you can use X and Y. Where is X positive? Where is Y positive? Okay, if you want to go that way, can. Change your free body diagram into two diagrams. One on the left is X direction only. On the right is Y direction only. Draw the X direction first. Ah. You understand what I'm asking, right? What do I ask?
X direction, right?
Where is your X direction? You tell me.
Right.
I don't know. You write on the whiteboard there. You tell me. Why there is a X and Y axis on the whiteboard? So where is your X direction? Okay. So why there is a P going different direction with your X? I'm asking you to break your free body diagram into X direction only and Y direction only.
This.
Why you become the examiner already? Why you change the question? The object was slanted 30 degree. Why suddenly you change the question to 0 degree? No, this is not the way you draw free body diagram. You can copy the body exactly that, but you just switch to X direction and Y direction. You understand what I'm asking? You know what I'm asking? You know what I'm asking? Draw all the force into X direction only. Do you know what's wrong with the diagram? Yeah, I'm asking Nico to draw the free body diagram correct already. I just want Nico to draw two more free body diagram, one for X direction only, all the force in X direction only, and one all the force in Y direction only. Two free body diagram. One for X direction only, Y for another one for Y direction only. What's wrong with the bottom diagram then? Why you change the question? Question is 30 degree. Why you draw like this? The force like this is correct. All this is all the force in X direction. So this is Px with this 100 T bracket cos 30. Why you draw like this?
Means we should keep this angle also.
Yeah. This one you already changed the question already. You become the examiner. Continue completing this diagram. Use the red color diagram. Again, the instruction is to convert all the force into x direction only. Is the one that you draw friction force in x direction? Again, where is your x direction? Then, what is the direction of your friction? I want to see x direction only. Other direction I don't want to see. Then, that is the friction force. Is that the friction direction? Friction direction correct. Is that the magnitude of the friction correct or not? You're still very weak in grouping x component and y component. This is your x, this is your y, right? This is your friction force, right? It's a vector, right? How you split vector into x and y direction? How you split this resultant vector into x and y direction? What is this one? Then how you draw this one?
Friction force.
Right. Then what else? What are the force that is missing in your free body diagram? Or you check again, how many force you have inside your free body diagram? How many force? How many force in your original free body diagram? 3, right? How many force you have here? Where is another one? Is it cos or sine? Okay, you go home, you do your homework now. Okay, you can go back to your seats. Once you draw your free body diagram, focus on surface. or forces. I will choose surface. What does it mean? I will focus on the motion, the object moving on the surface direction. You can fix go down positive. You can fix all the direction go down positive, means all the diagram you flip according to that direction only. I will follow all my direction here is positive. Go up, positive. I change all this diagram into that direction only. Mean how many force I have? I have 3 force. P, W, and C friction. I have 4 forces. Going down along the surface is positive. So this one I don't need to change. I break my W into 2 components. I break my NC don't need because only one direction go up. I break my friction into 2 components. So let's say go down X positive, go up positive. EX positive. This one W, I have WY, WX. NC, I have NCY only. F friction, I have friction X. Sorry. In this case, I only have friction in X direction, but negative. Can you see the diagram? Okay. Nickel, go home, do your homework. Free body diagram, you have a W, you have NC, you have P and velocity. Recall the equation of linear impulse and momentum. Just now, I already mentioned you need to break into X and Y direction. What is MVX? What is MVX? What is VX? 1. Eh? What is FT that you have? How many force you have? How many force? 1, 2, 3, 4. You have 4 forces put inside here, even though it gives you 0 impulse. Which one? My X go down positive. Which one do not inside here? And C. Right. So you have MV Vx1 plus first P positive because it's go down positive. Friction negative, Y negative times T, W sine 30. Nickel, go home, do homework. How to convert the degree into cos and sine. Okay, you make this one mistakes, you're going to lose at least 15 marks in your answer. One question is 25 marks. You miss this one, 50% gone already. Right? Go and practice why this one is sine and not cos. X direction not necessary is cos. You need to refer to the diagram. Right? Then you input all the, substitute all the value. Nickel, what is this integration answer? Integrate 100t dt, what do you get? What is the answer for this integration? If you cannot answer, you do another 10 integration homework. What is the next steps? 100t integrate dt. What do you get? How do you do integration? What do you get? Integrate x dx. What do you get?
T square root 2.
What is the final answer? What's the answer?
T
You do integration, you find you have NC and V2, you have two unknown there. You go to Y. So Y here, I say equivalent of equation of equivalent here, all the force in Y is 0, Y 0. Huh? Why the right hand side is 0? So your acceleration in Y is 0. Okay, it's not the static dimension. Huh? Static, you're looking at force only. Dynamic, you look at MA. Okay, so still the same. You use chapter 2. You can use the previous equation, but in Y direction, you can. Right, but in this one, I use chapter 2 for faster solution. Right, so I get my NC, substitute back to the previous solution. I get my V2. So you can solve using F equal to MA also, right? So you put inside there, get your A, then you use your dV, yeah, you use definition of acceleration, A equal to V dt. You want to find velocity, you integrate dV equal to A dt. This one you substitute back here, right? You do integration, you get velocity. And this is under equation of motion. You can solve using the previous one, we did this one. If the question directly give you instruction to use equation of principle of impulse and momentum, we did this one. You do for x, you do for y. You get two equation. One is in NC, one is in y2. You get 0 here. Okay, then you solve simultaneous equation. Okay, okay, we have a short break. 5 minutes break. So.